Hi there, Year 9. Today we are going to be carrying on looking at some work at similar shapes. We are going to try and do something a little bit more challenging. Perhaps try and work out some missing lengths by setting up equations. But first of all, we're going to look at a relationship between the ratios of sides in similar shapes. Okay, Year 9, can you make sure that everything that is under the visualizer today is copied into your books? So, one thing that you'll have already found out working on similarity from last lesson is this concept of a scale factor, the relationship between the two shapes. Okay? And what you will have noticed is that if you compare what I'm going to refer to as corresponding sides in a shape, there is your scale factor, and that is times by 2. Okay, another way of thinking about that is 12 divided by 6, so this corresponding side divided by this corresponding side equals 2. But also this corresponding side divided by this corresponding side also equals 2. So in other words, this side divided by its corresponding side is the same as this side divided by its corresponding side. That is always true for similar shapes. Now, one thing that Mr. Corbett didn't talk about is there is also a relationship between the sides on your shape. And let me show you what I mean by that. If I instead don't look at the ratio of corresponding sides, but look at the ratio just in each shape, there is a relationship between these numbers that also holds true. Let me show you what I mean. If I take this side, 12, and divide it by 4, 12 divided by 4 equals 3. What you might say, oh yeah, I can see the length is 3 times longer than the width. But if you now look at the similar shape, that also holds true for 6 divided by 2. So not only is there a relationship between the corresponding sides, there is also a relationship between the sides in the shape. And this concept and this idea is going to be really important with how we try and tackle our harder questions today. Okay, let's start by looking at a more difficult example then. I've just put a little paragraph to explain what it is that we are exactly doing. It says to solve harder questions, we can set up and solve equations using ratios. So here's my first example. And the first thing that you're probably wondering is, well, how do I actually know that these shapes are similar? Where are the similar triangles? Well, you've got a small triangle here, what I've called ABC, and you've got a larger triangle here, ADE. And the reason, if you are interested as to why these must be similar, is to do with these parallel lines. If you think back to our topic of angles earlier in the year, these two angles here, B and D, are corresponding because of the parallel lines. We also have a situation where there are some other corresponding angles. So similarly, angle C and angle E correspond to each other. And finally, both of these triangles have this same bottom angle in this corner. And one thing that we do know about similar shapes is if all the angles are the same, but the shapes are different sides for triangles, then they are similar. Okay? Now, the most confusing thing I think about this question is the diagram itself. So what I'm going to quickly do at the side is 2 additional sketches. One to represent this triangle with the information I know, and one to represent the bigger triangle. So let's look at the smaller triangle. In my sketch, this side would be x, and this side would be 8. In my larger triangle, this side would be 9, and the base, let's be a little bit careful, would be all of this length, which is 8 and 4, which is 12. Now from here, you could use the exact same maths as last lesson, find a scale factor and work it out that way. But I'm going to use this to show you how we can set up an equation and solve it. And I think for this one, I'm going to do corresponding sides within each shape. Okay, so I know x goes with 8 and 9 goes with 12. So if these are similar, as I've said they are, I know that x divided by 8 must be the same, and let's get the order right, I've done this divided by this, must be the same as this divided by this, because ratios in similar shapes match. So I know to get x by itself, I need to times by 8. Now you could turn this into 3/4 if you wanted, or a decimal, 0.75, but I need to do 8 times, I'll call it 3/4. And 3/4 of 8, divide by the denominator, multiply by the numerator, I'll let you use your calculator if you need to, comes out as 6 centimetres. I'll underline that answer. For our second and final example, we're going to have something really similar. I've just put the algebra in a slightly different place, and I'm just using some decimals in one of my lengths as well. So, just like the last question, I think the most important thing is to unpick this as 2 separate diagrams. Let me just put my parallel line in there. Okay, so for the same reason as example 1, these triangles must be similar. So I'm going to do a sketch of the small one, and I'm going to do a quick sketch of the big one. I know you'll be doing your sketches with a pencil. Okay, I'm just using a pen so it stands out on camera. So I have 6, I have 7. Don't worry about the fact that my 6 centimetres looks longer than my 7, because this just isn't drawn accurately. Okay, now slightly more complicated in my larger triangle, my base is now these 2 things added together. So this is x plus 6. All of that base is x, add another 6. And this side is 17.5. Okay, now this time I am going to do the ratios the other way round by comparing the corresponding sides on opposite shapes. So I know that this base links to this base. So those 2 things will form a ratio. And these 2 things will form a ratio. So I'm going to make an equation. Now, whenever you make an equation, you do want the algebra to be on the top of your fraction. So I'm going to start with this base, x plus 6, And since I'm pairing it with the 6, divided by 6 must equal, now I've started on this triangle, so I need to start on this triangle again, 17.5 divided by 7. Okay, now again, if you want to use your calculator, you can, because 17.5 divided by 7 comes out as a nice value. It comes out as 2.5. And now I just need to solve this equation. So I'm going to first of all resolve this divide by 6 by multiplying each side by 6. So remember, multiplying by 6 just removes the divide by 6, so I will be left with the numerator. So that is x plus 6. 2.5 times by 6. Well, 2 6s is 12, and half a 6 is 3, so that is 15. And then I just need to subtract 6 from both sides. And when I subtract 6 from both sides, x equals 9 centimetres. So in the activity that I'm asking you to do, I believe there's 6 questions. Use the remaining time that you've got left to answer as many as you can. Now, if that means you only get 3 done, 4 done, all of them done, it's what speed you work at. Also, what I would suggest is if you find this activity difficult and you want a little bit of support, just send me an email. Equally, if you would like me to do a video of all the solutions, I can do that for you. So good luck with today's work, but that's me signing out for today, and goodbye.